Now, let's prove the converse of theorem number 1. And we know the proof of the converse of theorem number 1 is not examinable. We are not going to be asked to prove the converse. We are not going to be asked to prove the converse, but we are going to prove it here. Now, with the converse, the difference, we still do the same thing, but the difference is that we are given triangle ABC with D on AB and E on AC. The such that part, with the theorem we said such that DE is parallel to BC. DE is parallel to BC. It is because of, we know theorem number 1 states that if a line is drawn parallel to one side of a triangle, then it divides the other two sides in the same ratio. That is why here we said triangle ABC with D on AB and E on AC, such that DE is parallel to BC. But in this case, we're going to say, with the converse, we're going to say, given triangle ABC with D on AB and E on AC, such that in this case we are not given that this side is parallel to this side. We are given that these two sides are in the same proportion. So we have D on AB and E on AC, such that AD over BD is equals to AE over EC. So it means that D is on AB and E is on AC, such that AD over BD is equals to AE over EC. We are required to prove that with the converse, because now is the opposite. Now we are required to prove that DE is parallel to BC. Proof. We still do the same thing. We draw DC, we draw BE. We draw the altitude of triangle ADE with respect to AD, which is your H there. We also draw the altitude K with respect to AC. Same thing that we have just done here. Area of triangle ADE, still the same thing that we have just done, which is half AD times height. We know how to get that. Area of triangle BDE, half BD times height. There's what we have there. Area of triangle ADE, we still do the same thing that we have done with the proof of the theorem. Half AE times K over the area of triangle CED, which is half EC times K, which is AC is equals to AE. Now, this is where we are at, but in this case, we are going to remove him after we have done this part and this part. We are going to say, but AD over BD is equals to AE over EC. Why are we saying that? We were given that. That's what we were given. Since this is equals to that, therefore this is equals to that. Same thing. Therefore, area of triangle BDC is equals to area of triangle CED. Since this is equals to that, Therefore, it means that this is equals to that. Therefore, DE is parallel to BC. Why is that? It is because we've got equal triangles on the same base DE. Obviously, if the area of this triangle is equal to the area of this triangle, if the area of this triangle is equal to the area of this triangle, it means that the two triangles have equal heights. And if they've got equal heights, it means that they are within the same parallel lines. Therefore, that is why here we say DE is parallel to BC. The reason for that is that equal triangles on the same base, equal triangles on the same base. So they are equal triangles on the same base. And why are they equal? Because they are on the same parallel lines. Therefore, this is how we prove the converse of theorem number 1. Even with the extension, you still do the same thing, because I'm not going to show the same way I've done with theorem number 1. Even with the extension, we still do the same thing that we have done, where we first going to give that triangle, given that triangle ABC with D on AD and E on AC, such that AD over BD is equals to AE over EC. This is the converse. We are proving the converse here. To prove that BE is parallel, since we are given that the two sides are in proportion, then we must prove that the two lines are parallel. If we are given two lines which are parallel, we can prove that sides are in the same proportion. That's theorem number 1. It's converse. If we have sides in the same proportion, then we can prove that the two are parallel. Therefore, that is why we still do the same thing up until there. But our but now is different from the theorem, where now this is what we are given, obviously. And since this is equals to that, it means that the area, the ratios there are equal. Therefore, these two triangles are equal. Then, since they have the same area, these two triangles, it means that they are in the same parallel lines. Therefore, that is why we say DE is parallel to BE is parallel to BC. Now, let's do an example on theorem number 1. Here, in triangle PQR, ST is parallel to QR. PQ is 32, QR is 16 centimeters, PQ is 32 centimeters, QR is 16 centimeters, PT is 25 centimeters, and we are also given that PS over SQ, PS over SQ is equals to 5 over 3. Let's repeat that. In triangle PQR, ST is parallel to QR, PQ is 32 centimeters, QR is 16 centimeters, that's what we are told. PT is 25 centimeters. We are also given that PS over SQ is 5 over 3. We are told A, to find PS. We are told to find PS, this length there. For us to find that length there, since we are given PS over SQ is 5 over 3, we can say let, number A, we can say let PS to be equals to, since I've got PS equals to 5 over 3, I can say PS is 5x and SQ equals to 3x. So I let this to be 5x, I let this to be 3x. Now, it means that then PQ is equals to 8x. So we know PS, we know SQ, we are given PQ to be 32, but we are given the ratio of PS over SQ, which is that. That is why we start by first saying PS, we let PS to be 5x, we let QX to be 3x, then PQ, it's 5x plus 3x, which is 8x. Now, we can say PS, what we are looking for, that's PS, over what we have. PS over what we are given, which is 32, the length of PQ. Therefore, PS over PQ in ratio form, what is PS? It's 5x. Over what is PQ is 8x, which is equals to 5 over 8. Therefore, PS over PQ is the same as 5 over 8. Now, we know we are looking for PS. Therefore, PS over, we know the length of PQ, which is 32. But this is equals to 5 over 8. Now, we can cross multiply, or no, even if it's not cross multiplying, we can remove this 32 here by multiplying by 32. And mathematics, whatever that you do on the left, you must also do on the right, times 32. Therefore, this cancels with that. We are left with PS to be equals to, obviously, 8 goes how many times into 8? Once. Into there, 8 goes 4 times here. 4 times 5, which is 20 centimeters. PS. Now, B. They said we must also find SQ. We must also find SQ. We can find SQ using 2 ways. Where we know the length of this, we also know the length of that. We can say this minus that, we find this here. So it means that if we want QS, SQ is equals to PQ minus PS. What is PQ? 32. Minus, what is PS? Our PS, we've just found it, which is 20 centimeters, which this becomes 12 centimeters, this part there. If we wanted to find PQ, we could have used what we have used here. We could have used what we have used here, where we're going to say SQ over SQ over the whole of this, over PQ, is equals to SQ is 3x over PQ is 8x, which this becomes 3 over 8. We know that we're looking for SQ over our PQ is 32, which is equals to 3 over 8. We can remove 32 by multiplying by 32. Mathematics, whatever that you do on the left, you do on the right. Therefore, this cancels with that. SQ is equals to 8 goes how many times into 8? It goes once. Into 32, it goes 4 times. 4 times 3, it is 12 centimeters, which is the same as that. Whether you use what we have used to get SQ, or whether you use this minus that to get this, it's still fine. Now, they say to us, C, find PR. They want us to find PR. And for us to find PR, I know I do have this. So it means I can use this. I do have this over that. So it means I can do this over that, however I prefer. Now, this is my B here, or B here, or B here. I can do B like this, or I can do B like that. Now, for me to find PR, I'm going to say PQ, because I want PR. So I'm going to say PQ, PQ, PQ over PS, over PS. Why PS? It is because I'm given PT. So that is why if I say this over that is going to be equals to this over that. I repeat, if I want the whole of this, I know I can say this over that, which is equals to this over that. Therefore, PQ over PS is equals to PR is equals to PR over PT. Now, what is PQ? PQ is 32 over. What is PS? 20 equals to. What is PR? We are looking for PR. Over. What is TR? 25. Now, if I say this multiplied by this, I'm going to have 20 PR is equals to this times that, which is 32 times 25. But obviously, I'm going to divide by 20 to get PR. What did I do? This times this, obviously, it is 20 PR. This times this, that is why you see 32 times 25. Therefore, that is why when I divide by 20 there, divide by 20 there, that's what you see here. That's how I got that PR is equals to 32 over 20 times 25. Now, obviously, this is going to be 40. I can see, yes, there. I'm going to have 40 centimeters there for my PR. Therefore, I do have from there to there, which is 40 centimeters. I do have from here to here, which is 20 centimeters. From here to there is 12 centimeters. Now, we are told to find ST. And for us to find ST, I want to remove here. For us to find ST, ST is there. But now we don't know the ratio there and there. Therefore, it means that we can first prove D. We can first prove that this triangle, and this triangle are similar. Triangle in green and a triangle in red are similar. Therefore, angle P is equals to angle P, because if I can separate these two triangles, this angle is the angle for this triangle, is also the angle for this triangle. Before I can start there, we want to prove that this triangle is similar to this triangle there. Therefore, we prove angle P is equals to angle P. Why are we saying that? This triangle and this triangle, P is common for both triangles. This angle here is equals to this angle there from part 1. This is an F shape. This is an F shape. Therefore, R angle QS, R angle QS is equals to T angle SP. T angle SP. Reason? Corresponding angles. Why are they corresponding? It is because TS is parallel to RQ. Obviously, the last angle, Q angle RT and S angle T, this angle is equals to that angle. That we know that when this angle is equals to this angle and this angle is equals to this angle, it means that the last two angles are equal. Therefore, it means that Q angle R, Q angle R, T is equals to S angle T, P. We can give the reason to be the third angle of a triangle. Third angle of triangles. Third angle of triangles, or triangle or triangles. Therefore, PTS, therefore triangle PTS, therefore triangle PTS is similar to triangle PRQ. Since the two triangles are similar, then we know that the corresponding sides are in the same ratio. The corresponding sides are in the same ratio. So it means that this over that, this over that is equals to this over that, which is equals to this small side over that. Because we can separate these triangles. I can separate these triangles. There. P there. R, Q. P there. T, S. That is why we said this angle is equals to this angle. Common. That is why we said R angle Q S or P, but because S was there, or P, R angle QS or R angle QP is equals to T angle SQ is equals to T angle SQ. So it means that this angle is equals to that angle. It means that this angle is equals to that angle. It means that this angle there is equals to this angle there. That is why we say they are similar. Therefore, we say that this, which is this, over this, over that, is equals to this over that, which is this over that, which is equals to this, because we're starting here over that, here over that, also here over that. However we wanted to do this, we could have found it. Therefore, I can say SP, which is SP over PQ, is equals to, because I'm looking, I don't need to use the, I can use that. I said this over that is equals to this over that, is equals to TS over RQ. You can see that. Oh, so we know SP. What is SP? 20. Over what is PQ? 32. Equals to. What is ST? We are looking for ST. Over what is RQ? Our RQ is 16 there. Now obviously, this times this is going to be 32 ST. This times that. Obviously here we're going to have 20 times 16. Divide, because this times this, obviously we've seen, I've just explained why is it going to be divided by 32 there. Obviously where we have ST. I can explain it again. This times this is 32 TS. Which is equal to this times this. 20 times 16. We are cross multiplying. This times this is that. This times that is that. But we want TS. That is why I divide by 32, divide by 32. That is why you see this side look like that. Therefore, this is going to be equals to, I can see this here goes 2 times. 16 goes into 16 once, into 32 2 times. 20 divided by 2, 10 centimeters, which is your ST. If we wanted, we could have used this, we could have used this over that equals to this over that. However we want. Here I started by this over that equals to this over that. If I wanted, I could have said this over that, which is the same as this over that. Where you start, that's where you end. If I wanted, I could have said this over that is equals to this over that. I was still going to get 10 centimeters.